Alright guys, welcome to Crown Smart. In this video we are going to be talking about differentiation. Okay, differentiation is simply f prime of a function. Okay, it's the rate of change of a function. Okay, now remember in our last video I said something about this function when we were doing this, when I was trying to find the giving a function, express the function in this form. So I explained that when you take the limits of this function and it exists, then that function is said to be what? Differentiable. So here this definition is actually the definition of what? First principle, and or is actually definition of differentiation, or we can call it the first principle. So it's defined as f prime of x is equal to the limit of this, okay, the limit of this expression as change in x approaches 0, and if the limit exists, therefore this function, any function given here, is said to be what? Differentiable. So let's start solving these beautiful examples. So here we have f of x is equal to x squared. Okay, so we want to solve this using the definition. Remember that our f of x already in question is x squared, so what we are looking for is f of x plus change in x. So my f of x plus change in x is equal to, remember that when we're given this kind of function, I want to find this. It means that anywhere I see x, I put what? X plus change in x. So anywhere I see x in this function, I put what? X plus change in x. So I'm going to have x plus change in x all square. So anywhere I see x here, I just put x plus change in x all square. Mind you that x square is equal to x all square. So that's the x. Okay. Now we expand this function, so we have that this f of x plus change in x is equal to x squared plus 2x change in x plus change in x all square. Okay, so we are done expanding this. If you go to your normal expansion, okay, this is a perfect square, and this rule I'm teaching you now, it's only applies to perfect square. So you just do the square of this. Now since the sign here is positive, I put it in front. Okay, then you do x times change in x, then always multiplied by 2. This is what we have, and then the last term plus change in x all square. So that's what we have. Okay, so the next thing is to go back to our definition. So we have f prime of x is equal to, then what is our f of x plus change in x? Okay, remember the limit as change in x approaches 0. Please, in some contexts, limits can be written as this or lim, so whichever one you like you can use. Okay, so we write the limit as change in x approaches 0, write x squared plus 2x change in x plus change in x all square. That is for f of x plus change in x. Now we do minus, what is our f of x? X squared. So this is all over what? Change in x. Okay, so this cancel this because plus this and minus this is 0. So we have this as the limit as change in x approaches 0. We have 2x change in x plus change in x all square all over change in x. We can actually factorize this. Okay, so this gives us the limit as change in x approaches 0. We have change in x into 2x plus, okay, change in x, sorry, that's change in x, that thing you're saying there is change in x all over change in x. So this cancel this. Okay, this cancel this. We are left with what? The limit as change in x approaches 0. We have 2x plus what? Change in x. Now remember our limits rule. So we're going to use limit by substitution. So we anywhere we see change in x, we put what? 0. So as change in x approaches 0, we just put change in x to be 0. So we have this as what? 2x. So whenever we differentiate a function x squared, we always have what? 2x, and this is equally your f prime of x. In some contexts, f prime of x can also be written as dy over what? Dx. So that's simply differentiation. Okay, we move over to the second question, which says that f of x is equal to 4 into x plus 2. Now if I expand this, I have 4x plus what? 8. So using our definition, remember using our definition here, we have that f prime of x is equal to the limit as change in x approaches 0. Now our f of x plus change in x. Now we want to find f of x plus change in x. Now, sorry to do this up here, but I just have to do it. Now, if my f of x is 4x plus 8, therefore my f of x plus change in x is equally, anywhere I see x, I put what? X plus change in x. So this becomes 4 into x plus change in x plus 8. So this is equal to 4x plus 4 change in x plus 8. So I expand this and I have this. Okay, so therefore my limit, go back to our definition, our limit, no sorry, f prime of x is equal to the limit as change in x approaches 0 of 4x plus 4 change in x plus 8 minus, remember this one is simply this, minus this minus, so the next one, f of x squared. F of x is what? 4x plus 8. Sorry, I'm supposed to put brackets. This bracket shows that it's one value. We're talking of f of x as a whole. So all over what? Change in x. Now this is equal to the limit as change in x approaches 0. We have this as 4x plus 4 change in x plus 8. Now if you open up, you have minus 4x minus 8. Okay, so all over change in x. So 4x can remove 4x and 8 can remove 8. So we are left with what? The limit as change in x approaches 0. We have 4 change in x all over what? Change in x. So this cancel this, we are left with what? The limit as change in x approaches 0. We have 4. Okay, now the limit of a constant is always a constant. Go to your limits room. The limit of giving care, so the limit of care is equal to what? Care. So the limit of this as change in x approaches 0 is simply 4. So that is your answer. That is just a beautiful answer of this. So the last but not the least, we have f of x equal to 3. So by definition, our f prime of x is equal to, okay, by definition is this minus this over this, taking the limit, right? Now let's go back. If f of x is equal to 3, remember our function, I said something in function. This is a constant function. Okay, why is a constant function? Because no matter the value of x from the domain you put here, you always, the range or the value you get in the codomain will always be what? This. Okay, so if I put f of 1, it's still 3. If I put f of 2, it is still 3. If I put f of 5, it's still what? 3. So if x is any value, 1, 2, 3, 4, anything you call it, the f of that x is equal to what? 3. So this makes it a what? A constant function. Okay, so here, if our f of x is 3, so our f of x plus change in x is equal to what? 3. All right, so we're gonna put this. So our f of x plus change in x is what? Okay, first put our limit as change in x approaches 0. So this gives us 3 minus, what is our f of x? 3. Okay, all over what? Change in x. Now this is equal to the limit as change in x approaches 0. We have 0 over change in x. Now 0 divided by anything gives us what? 0. So we have change in x, the limit as change in x approaches 0. Okay, 0. Now 0 is a constant, so don't get confused that 0 is a constant. 0 is a value and it's a constant, so it's a known value. Constants are known value. Okay, so 0 is a constant, so the limit of the constant is what? A constant. So this is 0. So in general, what this is trying to say is that limit of a constant is always, no, the f prime of x of a constant function is always what? 0. So whenever you differentiate constant function, let c be any constant function, so let f of x equal to c. So my f prime of x of any constant function is what? 0. So that ends the class for today. Please like and subscribe and share to your friends. Thank you.